welcome to this explainer. We're jumping right into a pretty mind-bending topic today. We're taking a deep dive into an invisible, slow-moving mega disaster that is quite literally unfolding right beneath our feet. You know, the most profound shifts in our world aren't always the loudest ones. So today, we're going to look at the science, the data, and the real-world evidence behind a phenomenon that honestly threatens the very foundations of our modern megacities. We're talking about land subsidence. Let's get right to it. When we imagine a disaster striking a city, our minds almost always jump to those sudden dramatic events, right? Earthquakes, hurricanes, massive flash floods. They announce themselves with a literal bang and cause instant, terrifying destruction. But I want you to consider a slow disaster. Land subsidence unfolds over years or even decades. It's a creeping catastrophe. But here's the thing, just because it's slow-moving doesn't mean it's any less destructive. Over time, the cumulative effects on our infrastructure, our ecosystems, and our populations can completely mimic the absolute devastation of those sudden dramatic shocks. So what exactly are we talking about here? Let's lay down a quick baseline. Land subsidence is simply the gradual sinking of the Earth's surface. And this happens because the materials beneath the surface are being removed, compacted, or somehow redistributed. Now, while this can occasionally happen naturally, the sweeping, large-scale sinking we are seeing across the globe today is overwhelmingly driven by human activity. We're manipulating the Earth beneath us, and the surface is reacting by giving way. In some places, this sinking is incredibly slow, imperceptible really, maybe just a few millimeters a year. But in other places, the numbers are absolutely staggering. 34 centimeters. That is over 13 inches. In parts of the world like Iran, the ground is literally dropping by more than a foot every single year. Can you imagine standing in your neighborhood and realizing the street level is dropping that fast annually? It's wild. This extreme rate in Iran is largely due to massive groundwater use and heavy agricultural irrigation. They're pulling water out of the earth so fast that the underground storage capacity, the aquifers, are simply collapsing. And the truly terrifying part? These changes can be entirely irreversible. Once that capacity collapses, it is gone for good. Okay, let's dive into section 1, why the ground sinks. So the leading cause of this sinking is groundwater depletion, and it works as a pretty simple 3-step chain reaction. Step 1, we pump water out of underground aquifers way faster than nature can rein it back in. Step 2, without that water down there taking up physical space, the pore pressure within the underground sediments drastically drops. Think of it exactly like a wet sponge on your kitchen counter. When it's full of water, it's firm, it holds its shape. But when you squeeze that water out, the whole structure collapses. That leads us to step 3. Those fine particles underground compact together and the land's surface permanently lowers. You've squeezed the sponge and it just cannot spring back. Water extraction is definitely the biggest culprit here, but it isn't working alone. Land use change and massive urbanization play huge roles as well. I mean, when we pave over the earth with concrete, we eliminate the natural pathways for rain to recharge those underground aquifers. On top of that, we are building massive, heavy infrastructure. Think sprawling megacities and massive skyscrapers, often right on top of really soft alluvial soils. This literal physical weight just compresses the weak earth downward. And finally, resource extraction. When we mine for oil, gas, and salt, we are actively stripping away the vital underground support systems that literally hold the surface up. Moving right along to section 2, anatomy of a slow disaster. By the time this sinking actually becomes visible to the naked eye, well, the havoc has already started. The ground rarely sinks perfectly evenly across a city, which means you get warped sewer lines, snapped railway tracks, and cracked roads. Ironically, as human development lowers these cities, their drainage systems actually lose their downward slope and just stop working entirely. Then you add climate change-driven sea level rise to the mix, and you've got a compounded flooding nightmare that absolutely crashes property values, skyrockets insurance costs, and eventually forces entire communities to abandon their homes. To really put a human face on these numbers, consider Maceió, Brazil. According to the data, mining-induced subsidence down there has damaged tens of thousands of buildings and displaced tens of thousands of residents. Because salt mining removed the vital underground support, an entire urban population had to pack up their lives and flee their cracking homes. It completely mimics the aftermath of a massive earthquake, but it happened entirely in slow motion. Which brings us to section 3, a global sinking crisis. And this brilliantly illustrates how this is a vast, worldwide problem driven by highly localized issues. We already mentioned the collapsed aquifers in Iran and the salt mining displacing thousands in Brazil, but look over at India. Megacities like Delhi, Mumbai, and Chennai are putting millions of residents at structural risk just due to the sheer weight of their urban expansion. Meanwhile, the Netherlands is looking at billions, yes, billions with a B, in restoration costs and depressed real estate values. And up in the Himalayan town of Joshimath, India, the land instability has become so severe that massive evacuations are underway and construction has been completely halted. Every region has its own localized driver, but the result is exactly the same. The ground is disappearing. Now, the crucial takeaway here is that we really have to stop thinking of this as just a coastal problem. Yes, sinking coastlines battling sea level rise face a very acute threat, for sure. But inland subsidence compromises critical infrastructure hundreds of miles away from the ocean. Many of the world's largest, rapidly urbanizing cities, including several right here in the United States, as well as over in China, are sinking at highly measurable rates. As global populations continue to grow and our reliance on groundwater deepens, the footprint of this hazard is expanding everywhere. So what do we do? Section 4, slowing the sink. Okay, well, we can't magically unsink the land once that major compaction has happened. We absolutely have actionable strategies to manage it and slow it down. First and foremost, sustainable water management. We have to regulate and drastically reduce our groundwater extraction. We need to give these aquifers some time to recover and even promote artificial recharge to pump water back into the earth. Second, smarter land use planning. Cities have got to avoid building heavy infrastructure in high-risk subsidence zones and strictly enforce zoning policies that protect natural groundwater recharge areas so rain can actually penetrate the soil. And third, technology and monitoring. Because, you can't manage what you don't measure. And measuring this threat has literally never been more precise thanks to INSAR, or radar interferometry. This is a cutting-edge radar technique that allows scientists to track ground deformation straight from space with millimeter accuracy. Think about that for a second. From orbit, we can detect if a specific city block has sunk by just a fraction of an inch. This gives local governments incredibly precise early warning systems, allowing them to guide their mitigation efforts and protect critical infrastructure way before a pipe snaps or a foundation cracks. So the core message today is clear. Land subsidence challenges every single assumption we have about urban safety. It forces us to completely rethink what a mega disaster actually looks like. It's not always a massive crash or a blaring siren. Sometimes it's just the quiet, persistent lowering of the ground right beneath us. But if we implement strict scientific monitoring, utilize incredible tech like INSAR, and commit to sustainable policies, our cities can withstand this creeping hazard before it becomes full-blown destruction. Which leaves us with one final, deeply important question to consider today. Is your city sinking right beneath your feet? The next time you take a walk down your street, I really hope you look at the roads, the buildings, and the water systems with a totally new perspective. The ground we stand on is far less permanent than we'd like to believe. Stay curious, stay informed, and I'll catch you on the next deep dive.